Welcome to another lesson on bearing and distance. Today we are looking at the subtopic combining sine and cosine rule. We'll be looking at cases where we have to combine sine and cosine rule to solve a question on triangles and bearing and distance. And before we proceed, we need to quickly remind ourselves sine rule and cosine rule. We have from here, if we are given a triangle ABC, sine rule states that A over sine of the angle A, that is A over sine A, is equal to B over sine B and is equal to C over sine C. And also, we have cosine rule states that A square is equal to B square plus C square minus 2bc cos A. B square is equal to A square plus C square minus 2ac cos B, and C square equals A square plus B square minus 2ab cos C. Now we may come across some questions where we need to calculate angles after calculating distance, and at times we may come across angles that are obtuse, that is, angles that are from second quadrant, angles that are more than 90 degrees. So at times when we come across those kind of angles, and when you are using cosine rule, we come across negative sign too. So instead of using cosine rule to find bearing and to find angles, at times we make use of sine rule. So that is why it is possible for us to combine the two to solve a question. Like we have this example, the first example, it says calculate the unknown side. There is a side A that is unknown. We are given side P, we are given side Q. Don't forget that the side facing an angle is represented with small letter of that particular angle, or the lower case. From here we have this angle as angle Q. The side facing it is small q, which we are given as 5 meters. We have this side as this angle as angle P. The side facing it, we are representing that one with small p, which is 8 meters. And we are given this angle R. We are to find this side, and we are to find this angle P and angle Q. And we need to remind ourselves the conditions for using sine rule and the conditions for using cosine rule. I'll quickly do a recap of that. For sine rule, we use sine rule when we are given a triangle and we know two sides and one angle, or when we are given two angles and we know any side, or we can put it as when we are given two angles and any side, or we are given two sides and the angle facing one of them. Those are the two conditions to be considered before using sine rule. For cosine rule, the conditions for using cosine rule, we must have two sides and the angle between them, or we can have all the three sides without angle. That is, we can have the three sides with no angle. So from this triangle that we have here, if you look at this angle, it is more than 90 degrees. We have 139 degrees, and we are given this side and this side. And if you relate this to cosine rule, we notice that we are given two sides and the angle between them. So the best rule to use here that will give us the answer is cosine rule. Sine rule will fail here because the two conditions to satisfy before using sine rule, they are not, this triangle is not satisfying them. So sine rule will fail. We use cosine rule, and from here I said something during the last lesson that this ABC is not in all cases that we'll be using ABC. ABC, they are just unknowns. We can also use PQR. According to what we have here, the question, they use PQR. So from here we have R square equals P square plus Q square minus 2PQ then cos R. And we know what P is. P is 8, so we have R square equals 8 square, and Q is 5 plus 5 square minus 2 into 8 multiplied by 5 then cos 139 degree. 139 is more than 90, but it is less than 180. So that means this 139 is coming from second quadrant. And from our abbreviation, all students take Coke. 139 from second quadrant, cosine is carrying negative sign from second quadrant. From here, this one is first, that is A, all are positive. This one, only sign is positive. Here, only tan is positive. Then here, only cos is positive. So this one, 139 is coming from second quadrant. Then this cos 139 will carry negative sign. So we have r squared to be 64 plus 25 minus 2 into 40. Then this will be minus cos 180 degree minus 139. 8 square is 8 multiplied by 8, and that will give us 64. 5 square is 5 multiplied by 5, giving us 25, minus 8 multiplied by 5 is 40. Then, since I explained earlier that 139 is from second quadrant, that is why this minus is coming in. So from there, the addition of 64 and 25 will give us 89 minus 80 into minus cos 41 degree. So from there we have r squared to be 89. I explained in the last lesson as well that we cannot subtract this 80 from 89. We have to multiply this 80 by the cosine of this angle before we now simplify it with this 89. So we have that as 89 minus 80. If you check our four-figure table for cosine, we check cosine of 41, that is, we go to cosine of angles under in our four-figure table and we check 41 under 0. So that will give us minus 0.7547. So we have r squared to be 89. Now the product of this and this, we have minus multiplied by minus to give us plus. Then the product to give us 60.377. Then r squared, if you add this, we have 149.377. Now when we have an expression that involves square, we have to take square root. This is r squared. So we take the square root of both sides. So by taking square root of both sides, we have r squared square root equals square root of 149.377. Then this square will cancel this square root. Then r from there is 12.2 meters. If you look at the diagram we have, obviously this side PQ is the longest side, and the answer we are expected to have should be more than 8. So when we are solving this and we have an answer that is less than 8, then we should know that something is wrong. We need to trace our steps back to this stage, because if you fail to indicate this minus here, that will affect the answer, and the answer that we are going to get will be less than 8, which is the wrong answer. So we must be very careful with that. When we have an angle that is greater than 90, we must know that it is from second quadrant and it will give us negative answer. Even if you press cos 139 from our scientific calculator, it will give us minus 0.7547 straight. But we are doing this for the sake of exam. In case we are not allowed to use scientific calculator, if we are only allowed to use manual calculator and four-figure table, so that we'll be able to solve what the question, so that we'll be able to write everything that we are required to write to solve the question. So after getting this distance, the next thing we do, since they are asking us to calculate the unknown side and angles, the next thing we do is we get one of angle P or Q. We already know what angle R is, so after getting P, then we can now use the sum of angles in the triangle to get the last angle that we need from there. So from there, using sine rule, I want to get P, so I will use P over sine P is equal to the one that is complete. Since for sine rule we have to combine the complete one, that is the one where we know the side and the angle with the incomplete one. So that's why we are combining this P with R, that is R over sine R, and our P from there is 8. So we have 8 over sine P is R is 12.2 divided by sine 139 degree. From here, by cross multiplying, we have this cross multiply. This will multiply this, and this will multiply this. So we have 12.2 sine P equals 8 sine 139 degree. We need to get P, but sine P is having a coefficient of 12.2. So we divide both sides. We divide both sides by 12.2, and we have 12.2 sine P over 12.2 is equal to 8 sine 139 degree divided by 12.2. This will cancel this. So we have sine P to be 8 sine. Now, this 139, as I've explained earlier, is coming from second quadrant, and sine is positive in the second quadrant. But to check this one from the fourth figure table, we need to remove this 139 from 180, and we have that as sine 180 degree minus 139 degree. Everything divided by 12.2. So we have sine P is equal to 8 sine 41 degree divided by 12.2. And that will give us, we have sine P to be 8 multiplied by, if we check our fourth figure table for sine 41, we have 0.6561 divided by 12.2. So from here we have the product of 8 and 0.6561. We have sine P to be 5.248 divided by 12.2. And from there we have sine P to be 0.4302. And we need P from here, but we have sine P to be 0.4302. So what we do here is we take arcsine or inverse of this sine of this angle. So we go to our fourth figure table and we open to sine of angles. So from sine of angles, we get the closest value to this. And if you do that, we have P to be arcsine of 0.4302, and we have P to be 25.5 degree. So that will be seen from 25 under 5. So we know P, we label this as 25.5 degree. We know P, we know R. Now we need to get Q. We have P plus Q plus R equals 180 degree. That is sum of angles in a triangle. So P is 25.5. We are looking for Q, and we know R as 139 degree equals 180. So we have Q plus 164.5 degree is equal to 180. Then Q from here will be 180 degree minus 164.5 degree, where Q will be 15.5 degree. And with that, we've obtained the unknown side and the unknown angles from that triangle. So with this, we have solved the triangle completely. So we label this as 15.5 degree. We have another example, but this is a question on bearing and distance. We are to sketch the diagram, And from the diagram, the triangle that we bring out, we know if we are to use sine rule or cosine rule by checking for the conditions that must be satisfied before using the two from the triangle. And after using cosine or sine rule for the distance, we use sine rule for the bearing, because the question is asking us for the bearing as well. The question says a surveyor leaves a base camp and drives 42 kilometers on a bearing of 0.32 degree. The surveyor A, we can just imagine that as someone that is leaving his or her house and driving through a particular route, covering a particular distance. So we can just look at that one. We can look at this question in that perspective as well. But we are talking about a surveyor A that is leaving her base camp and decides to drive 42 kilometers to a particular destination on a bearing of 0.32. That is the direction of movement. So after driving 42 kilometers, she then drives another 28 kilometers. For this 28 kilometers, she has changed her route. She moved on another direction on a bearing of 154 degree to get to her final destination. Now the question is asking us that how far is she from her starting point, and what is her bearing from her starting point to her final destination. Now we start by taking the first one. The surveyor leaves her base camp. So we can just sketch that one. We have these four cardinal points. This is north, south, west, east. So I will call this one A. The starting point, I will call it A. She drive 42 kilometers on a bearing of 0.32. So this 0.32 we have is telling us that the bearing is surveyor's bearing. The 0A is telling us that we are to start taking that bearing from the north pole, and we are to take it clockwise, the way a clock works. So from there we have this as 0.32, and that is 42 kilometers. So I will call this one B. This is north, south, west, east. Then the distance here is 42 kilometers. And this bearing is 0.32 degree. Now after getting to this place, she now changed her direction and she now move on a bearing of 154 degree. But here we can see that 42 kilometers is more than 28 kilometers. The line we use to represent 42 will be longer than the one we are going to use to represent 28. So we take that one. After getting to this point, she now changed her direction and she moved on a bearing of 154. This one is 28 kilometers. Then I will join the two. So I will call this one C. The angle from A to A is 154 degrees. Now the question is asking us that we should calculate our distance. This is our final destination and this is our starting point. We have to calculate our distance from our starting point. So that is this line. And there are some things you need to get from A. Like the first one, this angle A, we still go back to our Z angle. When we have Z angle like this and this, they are equal. We call them alternate angles. So as this place is 32, this place is also 32. Then the angle that we are having left here, I'll call that one SOC. This is south and this is the origin and this is C. So SOC from there is 180 plus 154 degree. It is 180 minus 154 degree because this is a straight line and the angle on the straight line is 180 degree, and we have this one as 26 degree. So this is 26 degree. then the whole of angle ABC from there, that is angle B. When we have this triple, we are talking about the angle at the middle, so that is talking about angle B. Angle B from there is just 32 degree plus 26 degree, which is giving us 58 degree. So the whole angle here is 58 degree. And if you look at the figure we have here, we have two sides and the angle between them. We don't know what angle A is, we don't know what angle C is. The only angle we know here is angle B. And when we have two sides and the angle between them, the rule to use there is cosine rule. So we label this one as small b, this one small c, and this one small a. So by using cosine rule there, we have b square is equal to a square plus c square minus 2ac cos b. And we know what A is, we know what B is. We don't know B, we know what A is, and we know what C is. So by substituting them, we know what angle B is. It is 58. So we have B square is equal to 28 square plus 42 square minus 2 into 28 multiplied by 42, then cos 58 degree. So by taking the square of 28, we have b square to be 784 plus 1764 minus 2 into 1176. Then we check our four figure table for cos 58. We have 0.5299. So by adding 784 and 1764, we have b squared to be 2548 minus the product of 2 and 1176 will give us 2352 into 0.5299. 58 is from first quadrant, so we don't need to subtract anything from it. So we have b squared to be 2548 minus 1246.3248 from our calculator. If you multiply this one and this with our calculator, so if you subtract these two, we have b squared to be 1301.6752. And we've gotten to a point where we have an expression that involves square. For any expression that involves square, we have to take square root of both sides. So we take square root of both sides. By doing that, we have this as square root of b square is equal to square root of 1301.6752, and we have b to be 38.1 kilometers. We have it as 38.06 kilometers from our calculator, but to one decimal place, I want to leave the answer in one decimal place, so we have b to be 38. The first decimal place is 0, but the digit we have after that 0 is 6, and for digit 5, between 5 and 9, they will be rounded up to 1. So this 6 will become 1. By adding 1 to 0, then we have 38.1 kilometers. That is our distance. Therefore, our distance from our starting point is 38.1 kilometers. We already have this place as 38.1 kilometers. The next thing to do is to get our bearing from our starting point. So we need to go back to our starting point and our final destination. And what we need to do there is to trace the angle from the North Pole, like this, to the line that connects our starting point with our final destination. And we already know this place as 32. So what we need to do here is to get this. When we get this, we now add it to 32, and that is our bearing from our starting point. And we get this angle here by using sine rule. So we have, using sine rule, if you look at the triangle we have, we notice that B is complete because we know the side and we know the angle. So we combine that one with the incomplete one. We are looking for angle A and we know side A. So which means A is not complete. So we have A over sine A equals B over sine B. A from there is 28. We have 28 over sine A is equal to 38.1 divided by sine 58 degree. So the next thing to do here is to cross multiply. When we cross multiply, this one will multiply this and this one will multiply this. So we have 38.1 sine A is equal to 28 sine 58 degree. And we are looking for A. We have sine A, but sine A is having a coefficient of 38.1. So what we do there is we divide both sides by 38.1. So we have 38.1 sine A divided by 38.1 is equal to 28 sine 58 degree divided by 38.1. So this will cancel this. And what we have there, we have sine A. If you open our four-figure table and we check for sine of 58, from our four-figure table, we have sine A to be 28 multiplied by 0.8480 divided by 38.1. And if you simplify that, we have sine A to be 23.745 divided by 38.1. So which means sine A from there is 0.6581. From here we have sine A to be 0.6581. We need to get A. And what we do here is we take arcsine of this value that we have here, or we open our four-figure table to sine of angles and we check the closest value to this 0.6581. So A is arcsine of 0.6581 and we have A from there to be 41.2 degree. That is this angle here, 41.2 degree. So reading this one, from this north pole to the line that connects the starting point of the traveler to the final destination, to the end point. So we have therefore the bearing from our starting point is equal to 32 degree plus 41.2 degree, which is 0.73.2 degree. And that's the final answer. We have this 0 in front of 73.2 because the bearing is surveyor's bearing, and we have to take it from the north pole to the line that connects A and C, doing that clockwise. So we have this 0.73.2 degree. So we have this third example also on combining sine and cosine rule. We are looking at the application to bearing and distance. So we have this third example which says a boat sails 4 kilometers on a bearing of 0.38 degree and then 5 kilometers on a bearing of 0.67 degree. The questions under it says how far is the boat from its starting point, that is from where is the boat started from. Then second one says calculate the bearing of the boat from its starting point. Now we sketch the diagram. The first distance covered by the boat is 4 kilometers, but on a particular bearing which is 0.38. So we have this, we have our 4 cardinal points, 0.38, we have this, that is 4 kilometers, 0.38 degree. So let me call this one P, or I should call it X. Let me call it X. It sails to a point Y. And then from point Y again, the boat now the sailor decide to sail further on a distance of 5 kilometers on a bearing of 067 degree. So we have this. If you look at the two lines, we notice that the one I used to represent 5 kilometers is a little bit more longer than the one I used to represent 4 kilometers. Then I will use straight line to join the two. So I will call this one Z. Then this is 067 degree. Now the first task from here is to get the angle that we need. Where there is a particular angle here where we have the information needed to get the angle, that is angle Y. From there I will label this one north, this is south, this is east, while this is west. From here I have angle SOX. I'm talking about this angle SOX. That is 38 degree. That is still taking us back to Z angle. That is alternate angles. So this one is 32. If you look at this angle SOE from here, SOE, this angle is a right angle. That is 90 degree. Right angle. And if you look at this other angle here, we have another angle there. That one is EOZ. Angle EOZ from there is 90 degree minus 67 degree, which is 23 degree. So this small angle here is 23 degree. So therefore we have angle XYZ. XYZ is talking about angle Y, the one at the middle. That is 32 degree plus 23 degree plus 90 degree. And we have that one. Sorry, this is 38. We have 38 degree. The addition of this will give us 151 degrees. So which means this angle here is 151 degree. So this side is small y, this side is small z, and this side is small x. So if you look at the triangle we have from there, we have two sides and we are given we have the angle between them. That is the angle we've calculated here. The angle between them is 151 and we have these two sides. And when we have two sides and the angle between them, we make use of cosine rule. So cosine rule will be used to generate the distance, because the first question is asking us for how far the boat is from its starting point. The boat started from here and this is the final destination of the boat. So we have to get the distance from this starting point to the final destination, and we represented that one with small y, and we use cosine rule to get the distance y. So for the distance of the ship from the starting point, we are making use of cosine rule, and says y square is equal to x square plus z square minus 2xz then cos x. So we have y square is the value of x from there is 5 square. The value of z, that is 4 square minus 2 into 5 times 4 then cos 151 degree. If you look at this 151, it is more than 90 but less than 180. So this one is coming from second quadrant, and from second quadrant cosine is negative. So we have this as y square is 25 plus 16. 25 is 5 multiplied by 5. We have 25, and 16 is 4 multiplied by 4. So minus 2 into 20. Then this one we have minus, because cosine is negative in the second quadrant, minus cos 180 degree minus 151 degree. So we have y squared to be 41 minus 40 into minus cos 29 degree. we cannot subtract 40 from 41. We have to get the value of cos 29 and we multiply the value with 40 before we now combine it and simplify together with that minus that is separating them. So we have y squared to be 41 minus 40. If you check our 4-figure table for cos 29, we have minus 0.8746. And from there we have y squared to be 41 minus multiplied by minus is plus, and that is 34.985. So if you add the two, we have y squared to be 75.985. And we have an expression that involves square. So what we do is we take square root of both sides. So by doing that, we have square root of y squared is equal to square root of 75.985. This square will cancel this square root. Then we have from there y to be 8.72 kilometers. So the boat is 7.82 kilometers from its starting point. Now the second question, the second part of the question is asking us for the bearing of that boat from its starting point. So that the bearing of the boat from the starting point will be taken from the North Pole to the line that connects the starting point of the boat to the final destination. And we already know this as 38 degrees. So, but we need from air to air. So the thing what we have to do here is to get this angle X. And if you look at the triangle, we notice that y is complete because we know side small y and we know angle y. But we are looking for angle X and we know side X. So we use sine rule. Using sine rule, we have x over sine x is equal to y over sine y. Our x from there is 5. So we have 5 over sine x is equal to y is 7.82 divided by sine 151 degree. And from here we cross multiply. So by cross multiplying, we have this. We have 7.82 sine x is equal to 5 sine 151 degree. So what we do here is we divide both sides by the coefficient of sine x, since the angle we are looking for is x. So by dividing both sides by 7.82, we have 7.82 sine x divided by 7.82 is equal to 5 sine 151 degree divided by 7.82. So 7.82 will cancel 7.82. Then we have sine x to be 5 sine. This 151 is from second quadrant, and we cannot check it from the 4-figure table except we subtract that 151 from 180. So that will be sine 180 minus 151 degree. We should also have in mind that sine in the second quadrant is positive. So this is divided by 7.82. So the distance of that boat from the starting point is 8.72 kilometers. Now we are expected to get the bearing of that boat from its starting point. So we need to get the angle from the North Pole to the line that connects X to Z, since X is the starting point of that boat. So by using sine rule, we have y is complete. We have the side and we have the angle. We combine with this angle that we need. We need angle X and we have side X. So we make use of x over sine X equals over sine y. So from there x is 5, so we have 5 over sine x is equal to 8.72 divided by sine 151 degree. So from here, the next thing to do is to cross multiply. When we cross multiply, this will multiply this and this will multiply this. So we have 8.72 sine x is equal to 5 sine 151 degree. So we divide both sides by 8.72. So we have 8.72 sine x divided by 8.72 is equal to 5 sine. This one, 151 is from second quadrant, so we do 180 minus 151 degree divided by 8.72. Sine from the second quadrant is positive. So what we have there, we have sine x to be 5 sine 29 divided by 8.72. If you open our four-figure table for sine 29, we have 5 multiplied by 0.4848 divided by 8.72. So the product of 5 and 0.4848, we have sine x to be 2.424 divided by 8.72. Then sine x will give us 0.2780. We need angle x, but this is sine x, and what we do there is we check for arcsine. We have x to be arcsine of 0.2780. We open our four-figure table to sine of angles and we check the closest value to 0.2780. So if we do that, we have x to be 16.1 degree. That is, this angle A is 16.1 degree. But the bearing of that boat from its starting point will be the angle from A to the line that connects x to z. So therefore, bearing of the boat from its starting point will be 38 degree plus 16.1 degree, which is 0.54.1 degree. The 0.54 is telling us that the bearing is taken from the North Pole clockwise, and that is surveyor's bearing. And with this, we've obtained the distance from the boat from the starting point, and we have also obtained the bearing of the boat from its starting point.